Hi, my name is Lily Amameni. In this short video, I will present our paper focused on improving verb understanding in video language models. This is joint work with Mathilde Caron, Arsha Nagrani, Andrew Zesselman, and Cordelia Schmid. Recent works have highlighted the strong object bias of current vision language models. This was first studied in images alone with the SVO probes benchmark, where they show that image language models struggle to distinguish between different verbs and often rely on nouns instead. For instance, it is easier for the model to distinguish between a positive and negative image caption pair when the subject changes from animal to woman than when the verb changes from jumping to kayaking. Park and co-authors showed this problem persists in video language models by proposing the multi-choice verb H benchmark with hard verb negatives. We will make use of this data set for evaluation in the following slides. In this work, our goal is to improve the verb performance of large-scale vision language pre-trained models without harming their noun performance. We start with clip for clip, contrastively trained on the video language paired spoken moments in time dataset as our baseline model. The first step we take towards improving verb understanding is to generate hard negative captions where only the verb has been changed while keeping the remaining context the same. For example, if the original caption of the video is two brown horses eating grass, we generate the hard verb negative caption, two brown horses running on the grass. We then train contrastively with these additional hard negatives in order for the model to pay more attention to verbs. We evaluate our baseline on the Verb H multi-choice benchmark introduced earlier. We then experiment with different methods of generating hard negatives, including rule-based methods such as replacing the verb by another random verb or by its antonym, and LLM-based methods such as using T5 or PALM. We observe that randomly changing the verb often results in sentences which are linguistically incorrect, and that antonym verbs are often not present in online dictionaries. On the other hand, LLM-based methods more often result in semantically correct sentences. We find that PALM-generated negatives work best. This works, but interestingly, we observe that naively adding in negative captions into contrastive training leads to some concepts being seen much more in negative rather than positive pairs. This results to harmful feature space distortions as the model can learn to either ignore or always predict some concepts. In fact, we observe a drop in performance on kinetics compared to our baseline when adding negatives in this way. To alleviate this problem, we propose a simple yet effective calibration strategy whereby we filter negative captions to balance positive and negative concept occurrences. Here we show confusion matrices for kinetics classes where the noun is the same but the verb changes to show the effect of the calibration. Without proper calibration, the verb phrase brushing hair becomes highly attractive in the video text feature space. This deteriorates the performance on all the hair-related classes. Our proposed calibration strategy alleviates this issue as shown on the right and avoids a loss in performance on kinetics. To further improve verb understanding, we use an LLM to extract the verb phrase from a caption. For example, the verb phrase eating grass for the caption two brown horses eating grass, and apply a contrastive loss to the isolated verb phrase. So in summary, our verb-focused contrastive framework consists of two losses, an isolated verb phrase loss and a sentence-level calibrated hard negative loss. Our method improves verb understanding compared to the baseline on a range of downstream tasks while maintaining performance on noun-focused benchmarks. Here we show qualitative examples from the Verb H evaluation. For each video sample, we show the 5 captions ranked in order of decreasing similarity. We observe that the baseline model often mistakes the hard negative as matching the video. For example, in the top left example, the caption, "A man is sketching a vehicle," is ranked higher than the correct answer, "A man is building a vehicle." When training with hard negatives, the model performance improves, retrieving the correct caption. To summarize, the problem we aim to address in this work is that existing video text methods are biased towards objects. We propose a framework which consists of 2 components, leveraging pre-trained LLMs to create hard negatives for cross-modal contrastive learning, together with a calibration strategy, and secondly, enforcing a fine-grained verb phrase alignment loss. Our method achieves state-of-the-art zero-shot performance on downstream tasks that focus on verb understanding while maintaining performance on noun benchmarks.